Hello and welcome back to Let's Code Physics. We are continuing to develop black hole battles. I've done a little bit of work off camera since the last time we saw each other. Oh, get away, get away. Ah, there we go. I think we had the level resetting the last time. One thing I've added is this vertical yellow line. We'll talk about the purpose for that in a minute. Another thing I added was I'm trying out a little bit with the enemy ship controls. Right now, the enemy ship is supposed to be flying in a circle. Of course, if I bump him off of that trajectory, he will careen toward a black hole. Oh, almost. Okay, so he's got himself a nice little orbit there. Let's see if we can get him a little bit closer there. So the real enemy controls need to be a bit more sophisticated than that. But this just shows I have the basics down of how to program it, although now I'm pushing him away from the black holes. But one other thing I changed, really just cosmetic, is I decreased the size of the collider circle for the black holes so that now, let me see if I can demonstrate this, when the ship collides with a black hole, it has a little bit of overlap. So it's not like before they were not quite touching and it was resetting and it was a little bit artificial looking. Now you can see on that last death that when this thing collides with a black hole, there's a little bit of overlap between the ship sprite and the black hole sprite, and that's because I took the or my prefabs. I took the black hole and I decreased its radius just a little, the circle collider's radius just a little bit. So the circle collider, when you view this thing, is just a little bit smaller than the sprite is. So if I pause the game and go into the scene view, I can click on one of these black holes, and you can see the circle collider there is a little bit smaller. The green is a little bit smaller than the sprite, just a little bit by, I guess that's by, that should be by 1.9 out of 20. 1.9 out of 2, so that should be 5% smaller. So just so that way it's, because the ship itself has, it's got its edge collider right around the edge, so that just allows them to have a little bit of overlap, just for make it a little bit more visually pleasing to look at. So that was just a cosmetic thing I changed while off camera. What I want to work on today is there's probably a more technical term for this, so please let me know in the comments what a more technical term for this should be. But I'm calling this the ship's look ahead. This is going to be an upgrade you can get to your ship in the game, where it shows you your ship's trajectory, that if you left it alone as it is now with all the forces acting on it, this is the trajectory that it would follow. Kind of like on they do this on Angry Birds Space. When you're in the space levels, you pull the Angry Bird back and it shows you the trajectory it would take, straight if you don't enter one of those gravity bubbles, and then circling around or orbiting around or spiraling around, whatever, once you enter one of the gravity bubbles. I think that would be helpful to the player. Like I said, that'll be an upgrade that you have to get later on in the game, so it'll kind of offset the higher difficulty of the future levels. But for right now, I would like to have that on my ship, because as I'm testing this, I think I would like to know, here's what's going to happen and here's how you might need to navigate. Also, that'll be a useful feature for the enemy ship to have, is to be able to avoid black holes based on its trajectory, so it can be checking its trajectory as well. So what I've done is I've created a game object, and the nice thing about this is these game objects, they can be physical, or I guess I say visible things. They can be a sprite, they can have a physical body, so they can have a collider, they can have mass, they can be affected by gravity, or they can just be a thing that is attached. It's like a bucket where you put things like scripts and graphics and things like that. And so the nice thing about this programming environment is that it treats all those things differently, which if you've been using Unity, you know all about that. If you're new to it, one of the reasons you should try using it, I think. So I've called this thing the look ahead, and what it has is a script that we're going to call plot trajectory. We'll take a look at that in just a second. But it has this line renderer on here, and basically that's where that vertical line is coming from. Is you give it the set of points, and it renders this line. Oh, look at that! I've already won. The enemy ship has collided with a black hole. So let's take a look at the script. So this script I have copied and pasted from a search, because if it ain't broke, don't fix it. So this is created by Herman Tulliken, posted to dev.mag.org or devmag.org. I guess that's there's the full URL up there. So I'll post a link to that in the notes below. And basically what this does is it uses I'm going to butcher the pronunciation here, but this uses a Bezier curve, I think it's called. I should have looked up the name. Bezier curve. Bezier curve. Bezier? A Bezier curve, which is basically an interpolation scheme for you provide the program with a few points, and it draws a nice smooth curve in between them. And so it is all nice and nested and has all these wonderful little chunks to them, so it's calling different subroutines, etc. But the part we're interested in is where it determines the points, and that's going to be, I think that's farther down. It took me a while to figure out how to get this updated, because there were some, if you copy and paste it directly from the site, there's some updating that needs to be done in terms of how things are called and everything, because I think it was made with an earlier version of Unity. Let's see, get drawing points, etc. Yeah, so these P0, P1, P2, etc. That's the points that it's looking to draw the curve between, and then that line render is just the curve that gets returned. And I am not seeing where I put in those points. So let's find out. Where did I give it the points? Vector 2. I remember. Oh, I know how to find it. One of the things I had to do in order for that line to travel along, I had to tell it to find the parent object. So one of the things you'll notice is that this look ahead is nested underneath the ship. So we say that the look ahead is a child object of the ship object, and so the ship is the parent object. So what this little piece here does is it looks for the game object's parent, and it's looking for its rigid body 2D. So the rigid body 2D is a thing attached to the ship that gives it its physics, and that's a way of accessing the transform. So if you say the thing's rigid body 2D, so the rigid body 2D is going to be called parent. If you access parent.transform.position, that accesses the transform here. It accesses the position, so that way the line will move wherever the ship does, which is pretty cool. So all I did was I gave it 2 points, right? So this list points is where the trajectory is stored. Maybe I should make a note to myself about that. List points is where trajectory is stored. And so basically I have it set up to where it has a point relative to the parent's location, right? That way it'll move with the ship. I add a vector of 0, 1 and 0, -1, so that's it going up and down. So that's why it's always vertical. Now, I think I can change the vector 3s to vector 2s. I think that's legal. Let's see what happens let's save this first, and then let's see what happens if I do that. Where is replace? There we go. So I would like to replace all instances of vector 3 with instances of vector 2. Let's see. Find all, maybe? All right, how do I do the replacement on this? Replace next, replace all. There we go. I think that could have been written out instead of done symbolically, but whatever. Actually, it's going to need to save before I run the code, isn't it? So before we do that, let's do a save a copy if we can. Yeah, yeah, save it as yada yada yada. We're in black hole battles. Plot trajectory. We're gonna call this one vector 3s. Okay, so I need to open back the original one because that's the one that the game object is tied to. So we're gonna go plot trajectory.cs. There we go. All right, now let's do our replace. So let's replace. Control H is replace, I think. There we go. Let's replace all of the vector 3s with vector 2s. Let's do in the current document, not the current project. Okay. Replace all. Although I get the feeling it's not going to matter, but we'll find out. Okay. Let's see. All right, let's save. Am I getting any errors? Errorless? Not getting any errors. That's always a good sign. It's always a promising sign. That can be a good sign. All compile errors. Yeah, that's what I thought. Okay, reload all. That's fine. Plot trajectory. The new namespace already contains one called plot trajectory. Oh, okay. So it doesn't like the fact that I've got a second plot trajectory in here. Plot trajectory v3. There we go. All right. Hopefully that was the only problem with it. Oh, what now? Oh, crap. That's all there. Okay, what I'm going to need to do is I'm going to need to... The problem is it's looking at all the .cs files in that folder, so I just need to move that out. Plot trajectory vector 3 cut. Let's move you up to just Unity projects. We'll just leave you there for right now. Now you're out of sight, hopefully out of mind. Oh, great. Reload all. Operator plus is ambiguous of operands of the type vector 2 and vector 3. That's on line 58. Parent.transform.position is a 3D vector. It just has a z component of 0. Okay, well then I tell you what. Let's put it back. Can I undo all of that? No, I cannot. Okay, so let's just put all that back. I think it'll work fine with vector 3s. I think I was just hoping to save some computer time by doing that. Instead, I've wasted video time by doing that. So let's exit out of this one. I haven't changed anything in this file. So we're going to do save as. We're going to go back into black hole battles, assets, and I'm looking for a plot trajectory. Save. Yes, please replace. Okay. All right, let's make sure. Okay, now that I've broken it, let's see if I put it back together. Nope, it is not rendering the lines. What did I do now? Oh, right, because I changed the name of this thing. There we go. Plot trajectory. It needs to be the same name. All right, let's try that again. Is look ahead? Yeah, it's still attached to plot trajectory. Let's see if I go into assets, plot trajectory. Yeah, it looks like it's reading it incorrectly. Yeah, there's vector 3. Okay, let's try that one more time. Okay, good. Okay. All right, I have now fixed the thing that I broke. So now let's try making it better. All right. So, okay, list points is where trajectory is stored, and I seem to have lost my color coding on this thing. I'm not sure why. Let's try opening it back up. Plot trajectory. I like the color coding. There we go. Okay, list points is where the trajectory is stored. Okay, so what we need to put in here is where the... Let's think about this. What I need to have in this list are points of where the ship is going to head next, which means I need to know the forces, the net force on the ship. So that is calculated over here in ship controls, right? Because I have this variable force on ship. I calculate the thrust vector. Okay, so RB2D add force on ship. Okay, what would be great would be if I could call that. I either need to pass this variable over to plot trajectory, or I need to pass this list over to ship controls. And I'm thinking that it's going to be better to pass the list. Okay, let's think. Okay, here's the thing I'm thinking about is this is underneath. This is getting called under its update, right? Because it needs to update. It needs to run once per frame. This is getting called under this thing's update, and it's getting called once per frame. The problem is, if I say, okay, access the force on ship variable, what if that force on the ship is incomplete? Like if it's in the middle of calculating, and like if ship controls is in the middle of calculating it and plot trajectory tries to access it, it's going to get the wrong information. So I wonder if what I could do. And now I'm very thankful that I have a copy of this saved over here. So let's call this one now backup. There we go. Now I'm glad I have a backup of that because that one I know works. This one I'm not sure whether it's going to work. I wonder if instead of calling this thing's... I wonder if instead of putting those under update, if I could call these three routines under ship controls. Let's give that a try. Let's see what happens there. So what I'm looking for is plot trajectory dot. Let's see. The first thing to call is get points, right? Yeah, is get point. No. Let's see. So what I want to do is I want to call the subroutine stored in here from this subroutine. Well, you know what? Let's actually, let's hold off on that. I know how to pass a variable. So let's pass force on ship over to here and see if it works. Because if it works, then I don't have to worry about it. If it doesn't work, then something went wrong. Then I need to do something else. Okay, so let's comment out these. I don't want to lose those because that's helpful. Okay, fine. You can tab that in if you want. Following lines are for demonstration purposes only. There we go. All right. So what I need is I need to get force on ship. So we're going to make a new vector2 force equals let's see what I say ship controls dot force. Oh, I wonder if I need to. Oh, I need to make that public, don't I? Yeah. All right. Where does force on ship first appear? Force on ship. Okay, so that thing's getting reset every time there. So what I want to do is I'm going to take that out. And now I need to make... see, there it's being stored as a vector2. All right, we'll need to think about whether I need to change that to a vector3 later. So here we're going to say public static float force. I thought I copied that. Force on ship equal to new vector2 0 float. There we go. Force on. That is how I've cased it. Is force uppercase on uppercase ship. force uppercase on uppercase ship. Okay, now I should be able to access dot. Oh, I need to save ship controls first. Save, and I should be able to access ship controls dot force on ship. Cannot implicitly convert type float. Oh, excuse me. I was just copying from above. There we go. Force on ship. There we go. Force on ship. All right. That seems to work fine there. Okay, so what I need to do here, let's assume that that gets the correct value of force on ship. We will be able to tell if it doesn't if the trajectory doesn't match the movement of the ship. Right. So what I need to do here is I need to put in, we've got to go back to our wonderful Euler-Cromer method. I might upgrade it to a Runge-Kutta later, but I haven't shown that on this channel yet, and I don't feel like teaching Runge-Kutta today. So we're going to start with a simple Euler-Cromer method. And now there is a way to get the time step on here. It's time.delta time. Okay. So what I want to do is I want to, let's increment it forward. Oh, well, I just need to pick a number of frames. So let's see here. So up here, let's put in public in frames equal to, let's start out with something nice, 10. That needs to be integer. This is number of frames to look ahead. And actually, I suppose that could be a way you could upgrade this upgrade in the game, would be to have the trajectory plot out for longer. So that's, we're going to call that in frames. There we go. And let's see here. So we're going to say for I equals 1, no, I wanted I, for int I equal to 1, I less than or equal to in frame. This thing isn't doing its usual mashable predictions. In frames, I plus plus. Do I want that in parentheses or in braces? I think I want it in parentheses. I will find out if I'm wrong. Let's see here. So what we need to do is we need to increment forward once. So let's see here. So we need to get a new position as well. So let's get a vector 3. So I will need to change this into a vector 3. So actually, why don't we go ahead and do this as new vector 3. Yeah. Although, no, let's leave it as vector 2. We're going to leave it as vector 2, and actually we're going to turn this into vector 2 as well. And I'll tell you why. It's because I don't want to accidentally change the z value of any of these things. I want that to just be left at 0. I don't want any error to creep into that. So we're going to call that position, and that is going to be parent. Is that what we called it? Yep, we called it parents right there. Parent dot transform dot, my preview is not showing up. I wonder why. Oh yeah, so this is going to be new here's how I'm going to do this. New vector 2 parent dot transform dot x, comma parent, oh, not transforming, parent dot transform dot position dot x, and then the same thing but with a y. There we go. Okay, the right squigglies are gone. It has accepted my offering. And then I need velocity, don't I? Vector 2 velocity going to equal new vector 2 parent dot transform. Oh, is velocity attached to the transform, or is it attached to the or is it's attached to the rigid body, excuse me. So that I don't need transform on there. I just need velocity.x parent.velocity.y. Okay, cool. And so Yeah, that ought to work. Okay, so now we do our Euler-Cromer method. So now we're going to use Euler-Cromer method to predict ship's trajectory. There we go. And so the first step is to update the velocity. So we're going to say velocity equals velocity. Excuse me, I'll get called out on this. Velocity plus equals. So the new one equals the old one plus the force divided by the mass. Excuse me, that needs to be parent dot mass times time dot delta time. There we go. Oh, except I'm going to need to update this force, aren't I? Yes, you are. Okay. Oh, well, in that case, I might as well just calculate the force anyway, I guess. So I need to calculate the force up here. I need to calculate force because it changes. I mean, I suppose I could read that in for now, but then we'll have to calculate the force down below. So then we have to update the position. So position plus equals velocity divide. We don't divide by parent mass for that, times the change in time. There we go. Okay, and now what I need to do is update the force value. So for that, I can go into here and just say I can take. Okay, it is for I equal int. Wonderful. All right, so let's take our. So now I need to calculate force, and so. Actually, I can save myself just a wee bit of computer time if I only calculate the force for all of them up until the last one, because on the last one, it's not cycling back around. So I might as well put in an if I is less than in frames. So let's see here. So I want to say that force equals new vector 2, 0 float, 0 float. Good. And now I need to do the same thing that I've got over here. I need to take this, copy and paste it, and we'll change the name force on ship to force. So let's see, we're going to change this to force. Let's access, where does grav cons come from over here? I'll need to make that a public static float. There we go. And now I can access ship controls.gravcons. Oh, excuse me, that needs to be public now. Public, there we go. Rigid body 2D, that's now the parent.mass. This is already accessing the black hole list, divided by all of this, which I actually need to create the R vector. Oh, I already have that up here. Haha, good. I forgot that was part of pasting it in. Let's see, I don't need that anymore. Calls transfer.position minus this just needs to be parent. Okay. I don't see any red squigglies. Oh, excuse me. I need a different I, don't I? Well then let's just change. Let's change this one to J. J. You have to make more red squiggly lines before you can get rid of squiggly lines. Okay, for J, so J is now being associated with my loop in time. I is being associated with my loop over the black holes. I probably could have called those IT and IB for time and black holes, but yeah, you know what? I better do that or else it's going to bother me. For IT. Oh, actually, that should be IF for frame. No, just leave it as J. Just leave it as J. I was about to say, oh, that could be IF for frame, but that's if, as in if right here. You don't get to name variables IF. Okay, so the last thing I need to do is actually add those to the points. So what I need to do here is say points dot add. I need to say position, right? Dot. Actually, let's do it this way because this needs to be a vector 3, and I've set this up as a vector 2. So we're going to say new vector 3, position.x, position.y, and 0 in the z direction. Okay, cool. So I've just added that. I should go ahead and add the ship's current location for a starting point. So let's do... let's just add the same thing over here. Copy, paste, points.add, new vector. Okay, so that's adding it to the points list. Okay. And I've got in frames set to 10, so I should get a decent trajectory, I hope. All right. All right, we've done a lot of coding. Let's see if that works. I've done a lot of typing, at least. Okay, cool. All right. So it's hard to tell whether it's giving me the correct thing. I think I need to increase the number of frames. And actually, it occurs to me I've left off the thrust force on there. So I also need to look up. I also need to be able to access the thrust vector. So rather than declaring that here, let's call thrust up here as I need to clean this up. I've got publics and privates together. Got public and privates together. The C junkies are going to be the not junkies, that's the wrong word. The C fanatics, that's a better word than junkies, right? The C fanatics are going to be yelling at me in the comments about my variable organization. Let's see here. Public static vector to thrust. Okay. And so we're calculating thrust down here. Right? Force on ship plus equals thrust. Okay, cool. Yeah, so I just need to copy that. Let's see here. That will go after that for loop, but still inside this if block. Force on ship plus equals... Oh, this needs to be force. This needs to be ship controls dot thrust. There we go. Oh, and I need to increase the number of frames. Let's make it way longer, 100. Here we go. Okay, it's still not showing me a whole lot. Let's see what happens as I get closer to a black hole. Okay, so I think that's working. Okay, so yeah, so right now I'm not moving a whole lot, and so it's not showing me a whole lot until I get close to the black hole and there's an appreciable force. Okay, yeah, it was zipping around there. Ah, okay. I don't like how it's just jumping forward like that. Maybe this is not as useful as I thought it was. Okay, so is this thing doing what I thought it would be doing? Let's ask that question, I guess. Let's see here. Under ship. Okay, yeah, so it's this thing in here. It is not showing a lot there. Let's take a look at it because it'll show me the elements. Okay, so it is calculating 10 points and it is storing those. Oh, you can even, I guess, is that a zigzag to show those 10 points? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is. Okay, so it's forming like a little spring thing there. That's cool. Okay, so it is giving me the 10 elements. It's just that the force on the ship is most often not appreciable. Okay, so that's kind of making me wonder whether I need to... Oops. I always press the play when I mean to press unpause, because play should mean unpause. And the fact that it keeps jumping like that indicates to me that, like, let's just hang out. Well, I can't hang out near a black hole, I guess, but come on, get away, get away. Like, the fact that it keeps jumping indicates to me that I might have that problem of where I need to worry about the two. We need to worry about the two subroutines talking to each other. So, okay. So that tells me I might need to go the other route, which is to call get points from ship controls to make sure that... But I could just have this thing calculate the force itself. I'm only pulling the force on ship once. Let's see what happens here. Okay, so I have the ability to increment forward 1 frame at a time. Okay, so those things are updating, which is good. All right, let's let it fall a little bit. Oh, see, this should mean unpause. It shouldn't be stop. Okay, let's see what happens with this thing now. I want to... Where's my ship? There's my ship. Let's see. I want to zoom in here. All right, let's see what happens to this thing as we get closer to the black hole. Oh, that's that's whenever I reset the scene. That's right. The thing does not seem to be doing much, huh? Boom. Okay, yeah. So this happens whenever I load a new scene. Okay. Well, that's weird. Okay. I don't like that. That's not what I wanted that to do. Okay, what if we change the condition? Here's what I'm thinking is, well, actually, let's do a little bit of diagnosis first. Let's see whether this thing is receiving the force as the ship controls is calculating it. So I got a little bit of cleaning up to do because I've got some print statements in there that I don't really want anymore. Do I have any prints in here? Okay, that's fine. We'll comment that out. What I want to do is I want to make sure that the initial force is getting passed to it appropriately. So let's see here. Where do we calculate force? All right, here's force on ship. Okay, here is the final value of force on ship. So what I want you to do, computer, is say ship controls says force is plus force on ship dot toString. Okay, cool. And then we'll go to plot trajectory. And when I call in force on ship, I do that up here. Print for me, please. Plot trajectory says force is plus force dot toString. There we go. Save. All right, and let's stop. I do want to stop now. Okay. All right, that's good. Ship control says force is 0.2.2. Plot trajectory says force is 0.2.1.1, 0.1.1, 0.0. So that, yeah, that seems to be passing along fine. Unpause, please. Let's get closer to a black hole. Whoop. All right, got way close to a black hole. All right, so that's run the spectrum of forces it should experience. Yeah, it's passing it just fine. 1.2 minus 3.4, 1.2 minus 3.4, 1.1 minus 3.9. Okay, so that's fine. I'm just not looking ahead far enough, and it keeps jutting out. I'm not sure why it's doing that, or maybe actually that might be a screen draw error. But what I think I'm going to try next is, instead of having it increment forward a certain number of frames, I'll have it increment forward a certain distance so that that look ahead is always the same arc length, I think is what I'll try. So yeah, I'll give that a try, and we'll see how that goes. Thanks for watching. See you next time. Bye-bye.